Lesson 30. Simple Classes. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. We can represent notes in music by a pitch and duration. Here we present a simple class which defines those two elements as an int and a double. The class allows us to bind multiple different data types into a single data type like this. In the main function, we declare an instance of our note class and assign it the value of a middle C with a quarter note duration. We can access individual members of our note using the dot operator. Middle C is a key approximately in the middle of the piano keyboard and is shown here in gray. In this tutorial, pitch values correspond to the white keys, with the keys to the right having positive values and the keys to the left having negative values. On the staff, the middle C looks and sounds like this. Notes above it have positive values, and below it the values are negative. In this program we have added code to reassign our note the value of a whole note that is 3 notes down from the middle C. That note looks like this. Executing the code, we see the values printed out for both assignments. This demonstrates how the members of a class can be accessed. To represent music, we need to have a sequence of notes like this. That melody is from Beethoven's Ninth Symphony. We can create a melody class and represent that melody as we do in this program. Our melody class contains an array of notes and an integer to hold the number of notes in the melody. In our declaration, we initialize our melody with this somewhat intimidating set of braces. In our class, we put an arbitrary maximum length of 20 on our array of notes. However, our melody only contains 15 notes. We can access the number of notes with a single dot. However, we need 2 dots and an index to access the elements of each note. This for loop prints out the notes in our melody. To give our melody a more full sound, we can add another simpler melody to accompany it. This one is just 4 whole notes. Putting these two melodies together, we get a much richer sound. We can create a new class called Song to put these two melodies together. Here we initialize the song with an even more elaborate string of braces. Our first melody has 15 notes, and the second has only 4. These two for loops output the notes from both the melody and the accompaniment. Using all of these dots tends to make code unreadable. To clean it up, we can use a reference as we do here in the first for loop. Comparing it to the second, you can see how this makes the code cleaner, especially if these values are used more than twice. We're going to give one more simple example to clarify what we have gone over and to present some terminology. In this example, we demonstrate the usage of a high score class. This class is composed of a name and a score, which are called data members. However, we will often refer to them simply as members. In the main function, we declare an instance of the high score class. When we do this, we say that we instantiate the class, and the process may be referred to as instantiation. The instance itself will sometimes be referred to as an instantiation too, but will more properly be called an object. This is where the name object-oriented programming comes from. In this example, we print out the name and score. These data members are accessed using the dot operator. We showed in the previous example that we can use the dot operator repeatedly to access data members within data members. This concludes the lesson.